I'm at 1:30. So today I will come to chapter 3, differentiation rules. And we have seen how to interpret derivatives as slopes and rates of change. And also we know how to estimate derivative of function given by tables of values and how to graph derivative of function. Excuse me. Um, we have used definition of derivative to calculate the derivative of function defined by formulas, but it could be tedious if we always had to use a definition, right? So we start to have some rules that finding derivative with like a shortcut way. Okay, so we're gonna have some formula to do it. All right, so let's start with section 3.1, derivative of polynomials and exponential function. Uh, so recall that let y equal to x be a differentiable function. We can express the derivative in several different ways. So according to the previous section, you should know that f derivative of x is going to be equal to the limit of fx plus h minus fx over h. For h, go to infinity. Okay. Let me highlight this. Okay. All right. Okay. And we can also write as df dx or d dx of f of x or dy dx. That's all of them in here. They mean that it's just f derivative of x. Okay, it just you cannot see sometime, but it actually mean that it is f derivative of x. Okay, so our goal is to develop some rules for computing f derivative of x. So we use limits only when needed. Okay. Um, what is constant function for fx equal to c, and we want to find the derivative of a constant function. And what happened? Okay, so if you remember from the previous section, you should know that for any constant function, we're gonna have a slope gonna be equal to 0. So you can just and if you use a limit, if you use the definition, taking definition by limits, you should know that so limit of fx plus h minus fx over h for h go to 0 will be equal to let me write down here, limit of uh, of c in here, c, because fx equal to c, right? But in here h gonna be c minus c, h over here. Okay, you should understand that f of x plus h, let me use other color, f of x plus h over here should also equal to c, because this is a constant function. So whatever input is always going to be equal to c, right? So that's the reason why I have f x plus h going to be c equal to c, and then whatever with h at the bottom, you know that the top now becomes 0, and divided by h at the bottom, So that's just going to be, so limit just going to be equal to 0, right? Um, so it means what? It means for any x equal to c, a constant number, then f divided of x should be equal to 0, right? Okay. Let's move to the next one. Okay, so here we're going to talk about the power function, which is very important for this section, right? We mostly gonna see a polynomial with some power on the top, such as x power n over here, right? So we want to take a derivative of that. Uh, if you try to derive, it with using the limit definition, you can see over here that I show you. For example, if f of x equals to x, I have f of x will be equal to the limits of x plus h and minus x, and then that's going to be left out on the edge at the bottom, top, and then I can cancel it and get only number one. Keep going with the same way and try for f of actual equal to square and see what is and see if there is some pattern happen things, and I know that it's going to be equal to 2x, right? So let's have the the case that x to power 3. Remember that the first one was x power 1, okay? X power 1. The first one was x power 1, and it's give me only 1. And for the second one, it's x power 2, and now it's come to x power 3. I still using the same the same method as before, which is using limit. And and if you follow off here, you can see that I always try to factor out the h to in order to cancel this h finally, and then direct substitute to get the answer as 3x squared. So conclusion, according to three of these example, I would like to have a pattern. So what pattern do you see? Okay, you see. Let's list it out. I have this derivative of x. Okay, derivative of x in here, because it's actually like we are looking for the derivative of fx when x equal when fx equal to x. So the derivative of x is equal to 1. Okay, and the derivative of so derivative of x squared will give me 2x. Okay, and keep going with the derivative of x to the power 3. I have 3 to the power x squared. So what do you guess for the derivative of x to the power 4? So you think you may gonna think about the power from the original function will become the coefficient of it of the sorry, it will become the coefficient of the derivative later. All right, so you can see here this number 3 now become the coefficient of the derivative. What about the power of the variable for the derivative? You see that the original was 3, right? For this one. But now the one in derivative become 2. So look like is lower 1 unit, right? So let's come back with x power 2 over here. Let me clear it out. You can see it was power 2 here, right? So in here is it, if you try to have 2 and lower 1 units, it's gonna be power 1, right? To power 1. And x power 1 is just x. Okay, so you don't even need to have number 1. Okay, so it still has the same pattern as that, right? So power from the original become the coefficient of the derivative, and the new power is a number that lower down 1 unit from the original power. Okay, so what about this guy? I have x here power 1, right? So I put down this number 1 to the coefficient of the original of the derivative. So where's the x of the derivative? The derivative of the variable in the derivative function should have a power that lower than number 1. So that's 1 minus 1 is 0. So x power 0. Keep in mind that x power 0 will be equal to 1. So you don't even need this x equal to 0. That is the reason why you have it equal to 1. The derivative of x equal to 1. So it's exactly go by that pattern, right? So I would guess that x power 4 become this number 4 become the coefficient number 4, right? Let me write it better. 4. And then x to power 4 minus 1. Lower than 1 unit for the power. Then it's become 3. Okay, so that is the pattern. Okay, now next, let's see the rule. Let's see the power rule. Which is, like I said before, like I say at first of this section, is we are trying to find the quickest way instead of using the limit, to find the derivative, right? So this is the formula. This is the shortcut way for you to handle the polynomial, to handle the value or the derivative for the derivative of a variable with the power, right? So in here we should know that we are trying to take the derivative of x power n, right? We see that this n, this power become the coefficient of the derivative function, derivative expression, I mean. And the power of the derivative will be the original one subtract by 1 unit. Okay. That is what we learned today. Let's try to do exercise number 1 below, and I will show you in the class when you come back with the class. But I can go ahead and do one more example in here for you guys. So if x equal to x power 6, then f of x will be 6 is from this power 6, it become the coefficient, and then variable x, and power 6 lower down 1 unit become 5. Okay, that is a way. So for the rest, I'm gonna let you guys do it. Okay, so okay, let's move to keep in mind that this rule actually works for both negative integer exponent and fraction exponent too. For completeness in the notes, here's 2 examples. Okay, so let's work on the example 1 with some negative integer exponent. So we try to take the derivative of let me see. Oh, here we go. You want to take the derivative of fx when x equal to 1 over x, which I can rewrite as x to the power -1. Okay. Sometimes if you see a fraction form with 1 over a variable, you can convert it to be power form. Okay. You should convert it to become power form. So such as note fx is in a constant divided by variable. Try to change it to be power form. So as x to the power c times x to the power -1. I can even make it more general as x to the power n, so then c times x to the power -n. Okay, so that is power rule. And yeah, if you see this, one note that outside this outside the guide note, I just want to tell you that you see a case that that's constant on the top and bottom with the form as x to the power n, you should change it to be power form, so you can do the you can apply the power rule easily. Okay, now let's do this problem. If you apply the limit definition, you can see that one f of x plus h will become 1 plus 1 over x plus h, and this guy is gonna keep the same. And if you do like LCD and then combine the rational, you will get negative h over x times x plus h divided by h, and then you can convert it to become multiplication between the rational, and then you can cancel the h factor between top and bottom, and you have 1 over x times x plus h, and then you have negative you can direct substitute and get -1 over x squared, which can be rewrite as negative of x to power -2. Okay, and so maybe I'm gonna rewrite like this so you can see -1 times with x to power -2. You don't know why I can do it, right? I don't know why I can convert this to be a power form. You can see here's a way, or maybe I'm gonna slower one more step to make sure people understand how can I have this, right? I have -1, I multiply it by 1 over x squared, and that one more step gonna be -1 times with x power negative 2. This gonna become negative x power negative 2. And that is a reason why now I can make a conclusion that the derivative of x power negative 1 going to be equal to negative x power negative 2. Okay. So, yeah. Let's do example number 2. We try to use this derivative to try to take the derivative of a square root of x, right? So in order to apply the power rule, I need to convert this square root become power. Okay, you should know that the square root is actually like a power of 1/2. Okay, or let me remind you that, right? I want to remind if you forget it. So I have, say, cube root of x will be x power 1/3. Okay, so what does that mean? The index of the radical become the denominator of the exponent. Okay, so what about I have, let's have square root of x to the power 3. Okay, now I have, if I want to change it to become power rule, right? I know that the top of the power of the exponent should be number 3, and the bottom is the index of the radical, which is the hidden number 2, because this is square root 2, right? Square root 2. Okay, maybe make more clear. So power equal to so x power 3/2. Okay, so yeah, so that is a remind from changing radical to become the power. So now I come back with taking the derivative of it. You can if you keep doing by using the limit, right? You should know that for x per h is gonna change to be square root of x per h, and fx will become square root of x, and for this case you should multiply by conjugate of it to make the square root gone, right? And then according to after you use conjugate, it just and simplify, it's just going to have h at the top, and then you can cancel with h at the bottom, and then you get limit of 1 over square root of x plus h plus square root of x, and now you can direct substitute and get 1 to power 1 over 2 square root of x. And if I want to write it as the power form, you can see it's going to be 1/2 times with x power negative 1/2. And now you're going to see that, oh, the derivative of x power 1/2 will be equal to 1/2. You see that? 1/2 times with x power 1/2 minus 1 become negative 1/2. So that still follow the power rule. See that? Still follow the power rule. And now we're gonna have like a general version, say that the derivative of x power n will be equal to n times x power n minus 1 for any n real number. Is a new real number. Okay. So yeah. Now let's try to do example number 3. Okay, so like I said before, anytime if you see a function that in the form as a constant over x power n, you should convert it to be power form, so you can take the derivative of it easily. So I would like to um, I would like to say this is in the c over x power n form, right? Right. So I would like to convert this to be 1 times x to power -2. So we can just write as x to power -2. Okay, now I'm gonna take the derivative of this. Okay, because the question is saying differentiate the following. So I will take the derivative of this by using the general by using the power rule. So the derivative of this will be okay. Now you should see that the power was -2, right? Put -2 in the front as a constant at the coefficient, and then variable is x. Oops. And now the new power from for the derivative gonna be the original power lower 1 unit. So let me write as you can see it, right? -1 -2 -1, and I can write it as -2 times x power -3. Okay, and you know I actually can accept this answer, but if you like to convert it in the form as as the fraction form or rational form, you can rewrite as -2 um, uh, uh, let me -2 over x power 3, right? So you instead of having a negative power, now I change to be a fraction form with a positive power. Okay. Either way, in here I will accept. Okay, both of this is going to be answer. So okay. Now, okay, good. This is a good example for you to convert it to be a power form. So we have y equal to cube root of x squared. Now I need to convert it to be power form, right? So remember that index will be the denominator. Okay, so what is the index in here? This one is index. So that's going to be denominator of the power. So I'm going to change its x to power something divided by 3. Okay, so the top will be number 2. Okay, because this 2 is not in the index. I'll just put in. Yeah. That is the rule. Okay, so I have now function rewrite as a power form, all right? So I can take the derivative of it, and I have like the y over the x, or if you want to write as y derivative like that, well, it's just going to be equal to, okay, I put 2/3 in the front, right? Now you have the variable is x, and the new power will be take 2. Sometimes the ink is run out. I don't know. So 2/3 minus 1. The original was 2/3. You subtract 1, and what is that going to be? I rewrite 2/3 here, and I have x to power. If you use calculator or you know how to do it, it's going to be 2/3 minus 3/3, which is become -1/3, right? And you know what? You want to convert it in back to the radical form, right? Firstly, you need to write as 2/3 times x power 1/3, right? And now you can convert it as 2/3 and cube root of x. So either this way or this way. I will still accept it is answer. Okay. All right. So I would like to let you guys to finish exercise number 2, and if you cannot do it, I'll get into my to the class, and we're gonna work on that. Okay. So now let's see some handy rules. The constant multiple rule, if C is a constant and F is differentiable function, then do dx of C times Fx, or actually like a derivative of a constant. So this is the derivative of a constant multiplied by Fx over here, and you can actually take out the constant outside of the derivative, so you can keep in mind that. Also, there is another handy rule is the sum or different rules in between two function. When you take derivative, you can just split it, and take derivative of each function. Okay, so let's do an example and see what happened, right? Okay, so I have f of x equal to x power 7 plus 8 times x power 5 minus 3 times x power 4 and minus 6 times x power 2 and plus 3x and minus 9. Okay, so so actually if you want to separate each term, you can right away apply the second rule of which is some or different rules to separate for each term in here. So it could make you easier taking derivative. I mean, usually, honestly, if you are very strong with derivative already, you don't even need to use this step, and you could just right away come to like taking derivative of each term right away. So anyway, just for now, just like step by step, we're gonna work like what we are learning right now, right? So so in here we trying to taking derivative of each term. You see that each term I'm taking derivative of it. Oh, not this one. And then this one here. So for x power 7, derivative of it, you should know that it's gonna be 7 times x to power 7 minus 1 is 6, right? Lower 1 unit easily. Okay, now, by the way, for the second term, I also apply the constant multiply by rule, multiple rule, because why? I saw 8 times x power 5, right? 8 is constant multiplied by x power 5. So I can pull out this number 8 in front, in front of the derivative, and then I mean, I don't have to worry about 8. If I see 8 multiplied by x power 5, I just move it out, and let's just take the derivative of x power 5. See that? Similarly, for the 3 here, negative 3 here, I actually just move it outside of x power 4 and take the derivative of x 4 only, and 6 2. You see that? And 3 2. See that? Okay, so now keep going. I'm gonna have to adding 8. I put 8 first, right? Now take the derivative of x to the power 5. I have to take 5 and put it in front of x, right? Remember that's this power 5 now become the coefficient of this x, and that's power, the power, new power gonna be 5 minus 1 and become 4. Okay, and now I move to the next term, minus 3 first. Okay, now I have to multiply it by 4 because this 4 I have to put down in front of x, and now this x has new power as 4 minus 1 equal to 3. Can you follow me? Okay, so minus 6 and multiplied by 2, put down, times x to power 2 minus 1 is 2 minus 1 equal to 1. Okay, what else? Plus 3. Okay, now the derivative of an x, if you remember from a special case above, the derivative of an x just become number 1. Okay. Okay. So let me note that the d of x, or the derivative of x will be equal to 1 always, and also the derivative of a constant number will be equal to 0. That from the first example. Okay, and then the next one is minus the derivative of 9. 9 is a constant number, so it's just going to become 0. Okay. Or I can, yeah, should be that, right? Okay, so now I have 7x power 6 plus 8 times 5 become 40x to power 4 minus 12x to power 3 minus 12 again x and plus 3. So far so good, and this will be the answer. Let me use highlight. Uh-oh. I cannot use highlight here. Okay, let me use the red one. Circle this. I always like to circle the answer so the reader can see it easily. So I really like if all of you circle the answer when you finish the problem. Okay. Okay, now let's move to example number 5. Okay. What happens if you see something like this? Y equal to x times 3x plus 1. Okay. Can you apply power rule here? Not really right away, right? What you need to do is you try to make it become power form. How? You must do distribution it, right? So I would like to do to multiply in, right? Do distribution, and I know that x times 3x will be 3x squared plus x. Okay, so now it's become power form, and I will apply general power form in here for you to see. I have y prime now to be 3 times 2, put down, x to power 1. Or I'm just gonna leave it as x. That's for the first term, right? You see that I at this time I don't even have to write something like the x the dx of 3x squared like before. Now I can write when it comes to the second step, because you know we we learned already, right? We learned to separately and applying the handy rule above already. So just gonna move ahead. Um, so we want to take the derivative of this x also, right? So the next term will be adding the derivative of x will be 1. Everyone know that, right? The derivative of x equal to 1. Okay. Simplifies. I have 6x plus 1. That's going to be the answer of the derivative of y. Okay. We move to example number 6. Wow. Now what we're going to do? We have x squared plus x plus 1, and we divide by square root of x. Okay. For this problem, can you apply the power rule right away? Again, no. So how can you do this one? I would like to say, actually later on you're going to learn about product rule and quotient rule. You can apply on to this problem if you don't like to use power rule, and if you don't like to convert it to become power form, you can use quotient rule and product rule in order to handle this problem. But for now, since you haven't learned that, you must convert it to be power form. Okay, how can you do that? Okay, let's firstly convert it to become x squared plus x plus 1 and divided by, what is this? Square root of x, going to be x power 1/2. Okay, now what? If you remember for the algebra stuff, you can change it to be divide for each term as x squared over x power 1/2 plus x over x power 1/2 plus 1 over x power 1/2. See that? Okay, now if you want to simplify it, you can rewrite as y equal to, so x power 2 over x power 1/2. If you still remember the power rule, you can combine this as x power 2 minus 1/2. That is for the first term. You add for the second term as x power, the top power was a 1, right? 1 minus 1/2. And then the last term will change to be x to power negative 1/2. So far, so good. And if you want to simplify it, you have y equal to x to power 3/2 for the first term, and then you have x power 1/2 for the second, and x power negative 1/2 again for the last term. Now you have the power form already. Okay, it is power form already, right? You can apply the power rule. So now you're gonna have y derivative as first term will be 3/2 put down multiplied by x to power, new power want to be 3/2 minus 1, right? And then you add with 1/2 put down multiplied by x to power 1/2 minus 1. And then plus with negative 1/2 put down x to power negative 1/2 minus 1. Oh, wait, for some power with fraction like this, I would like to like slowly you know, to do -1 on the exponent to make sure I don't mess up with it. So now I have simplify it. I'm gonna have 3/2 multiplied by x to power 3/2 minus 1. What is it gonna be? Gonna be 1/2, right? And we write more clear for you. 1/2, and then plus with 1/2 times x to power negative 1/2, because 1/2 minus 1 is negative 1/2. And lastly, I have negative 1/2 times x to power, okay, so negative 1/2 minus 1. Think about it, what is it going to be? Negative 3/2. Right? Okay, so look like actually I can say this is a solution already. No, this is, let's say this is derivative already. But someone say, I would like to convert it to be radical form. Okay, let me convert it for you to see. So I have 3/2 with a square root of x plus with 1/2 with I'm gonna say 1 and 2 square root of x over here, and minus with 1 over, okay, let me see. Uh, 1 over 2 square root of x power 3, right? So that's also another way at answer for the derivative. Hope this is going to be accepted by method 2, so you don't have to worry which way you can write. Okay, make sure it should be either form. Okay, so for exercise number 3, number 4, number 5, and number 6, I will let you guys to try it. Yep. And if not, if you cannot handle it, we're gonna see in the class. Okay, move to example number 7. Application. Find the point on the curve y equal to 2x power 4 minus x squared plus 3, where the tangent line is horizontal. Okay. So in here, you need to emphasize tangent line is horizontal. What happened with tangent line is horizontal? For the slope of tangent line, what happened? Slope equal to 0, right? And what does that mean? In this case, we need f the derivative of x equal to 0, because the slope of the tangent line equals 0, right? So when we have tangent line gonna be when you're gonna have derivative equal to 0, you have the original was this guy, right? Maybe I'm gonna, okay, you would like to find the I'm gonna write it as y derivative of x, right? You maybe had to find the derivative of x first. Okay, using the power rule, you can right away find it, right? Now you don't need to use limit stuff anymore. So you have y divided by x gonna be equal to 2, put down 4, power 4 over here, put down, right? 4 times x. Now new power gonna be 4 minus 1, 3 minus 2, put down, power 2 put down, times x. Power gonna be 2 minus 1, 1 plus 3 divided by 3 equal to 0. A constant become a derivative of a constant equals 0. Okay, so remember that derivative of a constant only is going to be equal to 0. If you see a constant with the variable, then it's not. Okay, I know someone gonna think about that, like, oh, take derivative of a constant becomes 0, then anytime you see a constant, that's going to be 0. That is wrong. False statement. All right, you still have the variable next to it. So all right, so now simplify this. What do we have? I have 8x cubed minus 2x at the derivative of x. Okay, I want to have y derivative of x equals 0. So then it means that this guy over here, x cubed minus 2x equal to 0. Agree? How can you solve this one? You have learned about math 115 or maybe Pythagoras or something like that. You should know how to use zero factor property, and you factor this out first. Always factor x. I'm gonna factor 2x. Have 4x squared minus 1 equal to 0. Okay, so either you're gonna have 2x equals 0 or 4x squared minus 1 equal to 0. All right, and for the first one, you're gonna have x equals 0. If you divide by 2, go inside. And the second one gonna be like x squared equal to 1 over 4, right? And if you square root both inside, you're gonna have this as x equal to positive or negative 1/2. Remember that when you square root of a square variable, you're gonna have a positive and negative stuff. Okay, so maybe I'm gonna write as you know what? Let me write like this so people can have more clear. So square root of this, square root of this, and x equal to 1/2 or equal to negative 1/2. So I have 3 things. This one, this one, this one. 3 of these value of x will give you f derivative of x going to be equal to 0. Okay, are we gonna stop here? Actually, no. We need to let me see. You need to know that we are trying to use other color. We are trying to find the points, right? Find the point on the curve where tangent line is horizontal. And if you guess from the graph, you're gonna say, oh, maybe, oh, this one from here, from this point, you're gonna have like a tangent line. This point also gonna give you a tangent line, and this point also gonna give you a tangent line. But you know, how can you coordinate it? How can you have an order pair point, right? You know, say at x equal to 0, right? Here's x equal to 0. what is the y value? I have y. Now I have to come back with this equation, right? I take 2 times 0 to the power 4 minus 0 to the power 2 plus 3. And um, I will have 3 as y equals 3. So then, um, I would say this one over here is the point going to be as 0, 3. Okay. What else? At x equal to 1/2, I will have y equal to 2 times 1/2 power 4 minus 1/2 square plus 3 equal to use a calculator. You actually can have 20 thirds over 8 for this one. Ooh. And then you for this one, whereas on let me use other color. I'm going to use the green one. Okay, so you would say, oh, from here you should know that this point, right? This is a 1/2. It is 1/2 and 23rd over 8. Okay. And the last one was at the black one. X equal to -1/2. Y equal to 2 times 1/2 over 4, -1/2 over 4 minus -1/2 square plus 3, and that still give you 23 over 8. Okay, so you can, from here you can also say that this point is -1/2 comma 23rd over 8. Okay. You can write it as decimal number, but I usually write it as a fraction number or rational number instead of a decimal number because it's more accurate. So yeah, that's it. Okay. So we have just finished the problem, but I would like to state 3 points here. Maybe I'm gonna use blue color and then just gonna circle it. 1 point, 2 point, and 3 1. Third one. Okay. Now let's move to the exponential function. Okay. How can you take a derivative of an exponential function? Let's try by using the limit, right? And let's see what happens. So you have let's find the f derivative of 0 first and see what happens. So you have plug in here for f of x plus h when going to be f of 0 for h minus f0 over h. So I can rewrite it as limits excuse me, remember that we are using fx equal to bx over here, okay? So f of 0 plus h now become b to power 0 plus h minus b power 0. Everything divided by h for h go to 0. And that's going to give me the limits of b power h minus 1 over h. H go to 0. And that's going to be equal to limit, let me see, you can, for this case, what you should do now, you know what, you cannot cancel h in this after this, so I would say I stay here and say this is a expression for f review of 0. Okay, I'm just gonna keep in mind that because later on I'm gonna use that for f review of x. Okay, now let's see. So for f review of x gonna be equal to limit of fx plus h minus fx over h. Let's expand it. So it's gonna be limit of b power x plus h, right, minus b power x over h for h go to 0. That will give me limits of b to power x times b to power h. Remember that b to power x plus h can be rewritten as b to power x times b to power h. And then I minus for b to power x here, divide by h. For h go to 0. Okay, so now what you can do is you're gonna try to factor the bx for the top, right? So let's see. I have equal to the limits factor the b of x for the top. Let me use this one for you to see here. There's common factor, which is b of x. So I have b of x and it'll be multiplied by b power h minus 1 over h. H go to 0. So what are you gonna have right now? After this step, you wanna take a look back here. You see that there is a the limits of b of h minus 1 over h here. Let me use icon. This one is what is a value of 0. So I actually can rewrite this as limits of h go to 0. Oh no, sorry. I can just move out the bx. because this doesn't have any h, and multiplied by limit of ph minus 1 over h. Okay, and you can see that, oh, now it's just going to become b to the power x times f divided of 0. Okay, so what does that mean? From now on, you can have a rule for taking derivative of an exponential function. We're going to be like f derivative of 0 times b to the power x. All right. Okay. So what else? All right. Let's move down here. Of all possible choice for the base b in number 1, is this guy. The simplest differential formula occur when f derivative of 0 equals to 1. We denote this special choice of base b by the letter e, and is the same e where we encountered in session 1.4. That means with base b equal to e, then f derivative of 0 is going to be equal to 1. Okay. If you change b equal to x, the number, the e number, right? Or someone call like ordinary number, something like that. Then the derivative of s will be equal to 1. Okay, so then the derivative of 0 will be equal to 1. So we're gonna have f derivative of x will be equal to e of x. So what does that mean? Okay, let's go down to here. Definition of number e. Okay, so if you guys should know that e is the number such as limit of e to h minus 1 over h. Going to be for h go to 0 is really equal to 1. Okay, and that's the definition of number e. And the derivative of the natural exponential function will be itself. See that? Itself. The derivative of e to the power x is going to be e to the power x. So the fact is going to be, first, e to the power x is its own derivative. And this is only true with base e. And this is only non-zero function which it is its own derivative. Okay. And take a look at the graph over here, which is a graph of e to power, no wait, the graph of y equal to e. So wait, no, y equal to e to power x. Let's read that. Yep, it is a typo. Okay, so this is a graph of y equal to e to power x, and if you take a look at the tangent line at point 0, 1 over here, then you should have a slope equal to 1. Okay, whatever the value of y is going to be, the slope going to be equal to it, right? For each point in here. So for example, at point x comma e, the value was e, then the slope just becomes e. So it is its own derivative, right? All right. Let's do an example number 8 over here. You can see that if you write as y derivative will be The first one was power rule apply. So 5 times x to power 5 minus 1 is 4, right? Next one, plus with 2, the constant multiplied with something, just move out constant, time with e to power x derivative, what will be itself, e to power x. And then derivative of 3 going to be 0. Okay, so 0. So that's I'm gonna rewrite as 5x over 4 plus 2 to the power x, 2 plus 2 times e to the power x. Okay, so that should be the answer for this part. Let's move down and see. Okay, so we have exercise challenge number 8 for you guys, and also number 9 for you guys. Okay, and then I'm gonna assign you for product rule and quotient rule video for next class. Okay, I will provide you for also for the product rule and quotient rule, and also we'll talk about the next class later. And okay, and I don't want to have handout I don't have note for section 3.2, but I will have the video for product rule and quotient rule for you guys later. And we are gonna stop this section here and see you guys later. Bye.